Last time we talked about some of the basics of text file processing, primarily why we want to do this. Text files are the most transportable type of file. We can read them on Macs, we can read them on mainframes, we can read them on desktop computers, we can read them from the web. Most mobile programs can read text files, so they're very, very transportable. Unlike Microsoft Word, where if you don't have Microsoft Word installed, you're kind of out of luck. Even executable files are not as transportable. They're just ones and zeros, but they're ones and zeros targeted at a particular type of processor, the particular type of operating system. So what I want to show you first, just as a real quick demo, is how I take advantage of text files. My assignment or my attendance program has all your names and the fact that you're in this section. And I could type all those manually with your ID numbers. I'd probably screw it up, mistype a couple of your names, and maybe put you into the wrong sections. Plus, with 6 classes, 100+ students in those classes, that's an awful lot of work. And so what I found is a way to grab a text file and then go from there. So I want to show you the way I do that. It's not anything you have to follow. This is for your information only. I'm using my access to my MSTC, primarily because Blackboard didn't exist when I built this system, so I'm just using it and continuing to use it. What I do here is what I need to grab from here is just about everything about this course, including you and what semester I'm in. So here's the semester, here's this course section number, here's the course name, and there you all are. So what I do is start with the information that I need and just drag. Copy that to the clipboard. And then open up, in my case, Notepad++, but I don't have it on this computer, so Notepad, and paste it in there. So now you can see there's Eric's name, and there's Jess and Lyle, and all your names are there. But what's all this other nonsense? Well, everything I highlighted. And up at the top is the spring and a bunch of other nonsense and some other nonsense. And there's my section number. There's the program course name. Here's the days of the week that it meets. But how did I turn this into that? It's called programming. I had to write the logic to say, okay, that first line, I need the semester. So I used string processing, part of what you're going to learn this semester. I used some string processing to strip out the spring 2015. Unfortunately, at Midstate, our semesters look like this, so I also had to write code that says start with a 1, then strip out just the year, the 15, and then if it's spring, give me a 2, if it's summer, give me a 4, if it's fall, give me a 6, because that's the Midstate super secret code for semesters. Just got done with RDP, right? It's another stupid thing to do, super secret codes for stuff. Why can't we just put spring 2015 in there? Because they don't sort right. The other method, the 1-15-2, the spring of 15 shows up first, then the summer, then the fall. So that's one reason to do it. But making me work with it, that's painful. And then I have to say ignore the rest of that line and keep going until you find a line that has parentheses in it. I think that's my logic. I've forgotten. As soon as you find parentheses, stop, grab the 5 characters after the parenthesis because that's the section number. Ignore the rest of the line, keep going until you get a line that is not blank, or maybe my logic is the next line with parentheses. Grab everything in front of the parentheses, trim the spaces off of that, that's the course name, okay. Then go find probably this line with days on it, skip it, go to the next line because that's got the days and it's got the times. Are there any more day lines down there? There's another one. Grab that Thursday. My attendance tracker, I don't know if you've ever noticed, I bring it up and it knows what class I'm in. Magic. No, programming. The computer knows what time it is. This program knows that at 1 o'clock, I'm teaching programming logic beginning, automatically brings it up. I can still switch, but it automatically brings it up. And that's why I do this stuff. And the rest of this, who cares who the instructor is? I think the room number, I don't care anymore. I used to. And so I go until I find a line that probably starts with photo or maybe enrolled students. I don't remember what the logic is, but this is what you kind of have to figure out when you get this hodgepodge of text. What from there do I need, and how do I find it? And so once I find enrolled students, then move down 1, 2, 3, 4, 5 lines or whatever it is. Grab Robert's ID number, move down 2 lines, grab Robert's name. Stupid program doesn't put a space after the comma. So let's add a space. I don't really need his middle name, so let's get that out of there. All this gets done behind the scenes. The good news is I write it once. I write the code once. I don't go sit here and analyze this every semester. I paste it in here, and then I go back to my attendance program, and down at the bottom there's a link that says import. And it says, where's the file? I haven't saved it, so this isn't going to work. Then I push the import button, and that's where all of the intelligence is. And it just does it. And so at the beginning of every semester, I go to every class, I highlight, paste, save it, import, done. All the sections are created. You are all put into the appropriate sections. If your name's not already in the database, it adds it. If it is, it's smart enough to leave it alone. Magic. Turning you all into magicians. So now let's learn a little bit more about how to read this. The latest and greatest version of the program I gave you that's on OneDrive should already have in it a roster file in the bin ex or debug exe file. There's a roster.txt, and I believe, yep, that's 5K. So this one should have all that roster stuff in it already. Now notice I also made my program smart enough to skip blank lines because it's a real pain to be careful enough to highlight exactly right. If I get a couple of blank lines that shouldn't cause any trouble, doesn't. Did the first couple of times, I said this is ridiculous, and I added some more code and said skip blank lines. So that's there. Why is it in the executable folder? Somebody remind me. Pardon me?
So you can share it.
Louder.
So you can share it when you send the file out to somebody in the program.
Okay, that's a good point, because if I want to share this magical program with somebody else, they're both in the same location. That's pretty easy, but what's the primary reason? Nathan?
You don't have to write a complete directory to it.
Good, I don't have to write the complete path to it. Directory is another name for a path. You don't look old enough to know enough DOS to use that term, but okay. Aaron?
Is this where class files will be saved as?
No, class files, Aaron's hung up on class files today. That's cool. All right. We're going to learn that in the second part of this unit. The class files are embedded inside your Visual Studio project, just like my Volker tools. They aren't saved anywhere. You can find them, but the executables got all that wrapped in it. Okay. So when inside my program, when I write the piece of code that says go find that file, all I have to say is roster.txt. If that file were stored somewhere else, I'd have to provide the complete path to that file. It's on the server, on the network drive, in this folder that has this folder, that has this folder, that has that folder, and there you'll find the roster file. That's perfectly acceptable as well, but this is the easiest way to deal with it. Just put it in the same folder where your executable is. And that's not hard once you have your executable. The problem I have is I remember that folder is optional. This debug, the bin folder is optional. You can delete it, and it has no effect on your project. Of course, if I delete the bin folder, my roster file just went away. But if you're trying to save space, you can delete that. You can delete this one too. They're automatically recreated every time you rerun your program. It creates those. And it has no effect on your program. You can delete those, save space. They'll come back, and it won't cause any trouble. Don't do that one, though. Just those two. I save all of your projects from last semester. That's a lot of projects. And so I actually tell Windows to go through and find all those bin and object folders and then delete them. It's a half-hour process. Once I hit delete, it takes Windows a half an hour to go through all those and delete them. There's a lot of them. So they take up a fair amount of space. You can get rid of those if you wish. You don't have to. Okay. So last time we talked about how if we want to process a file, we first have to put the using statement in here. You don't have to, but it makes life a lot easier. And then we went down to the button open click event, defined a pointer to that file. This pointer serves two purposes. It finds it on the disk, where is it located, points to it, and it also keeps track of within the file which characters am I currently looking at. So it kind of walks down the file as we read. We haven't done any reading yet. Once we have a pointer defined, that's just a generic pointer. It's pointing nowhere. The recording purposes, my hand's waving in the air, I'm pointing to nothing. This is a pointer, and it can only point to a Streamreader. Streamreader is a class that's built into Visual Studio. They gave it to us so that we can read from text files. Next thing we have to do is open that file. Remember, there were 4 steps. We had to create the pointer, open the file, process it, and then close it. So here we're opening the file so that we can start reading from it. That also has an effect of putting that pointer at the very beginning of the file. At this point, it points nowhere. Now we're saying use the file class, that's also built in. Use the open text method that's built into the file class. And find this file. We used a constant here. It finds it, and it makes this file pointer point to the very first character inside that file. So now it's ready for us to read from. The file is open. Windows has given us access to it. Somebody else tries to open that file. If you try to open it, this is always a problem. You open it so you can see what's in it, and then you try to run from it, and you can't open it in 2 different programs. Windows and your program can't see both of them. So you have to, sometimes you can get away with it, depends on what you're doing to it. All right, so this opens the file. Then we're going to read it. We skipped that step because you should always close the file. Good programming style dictates that if you open a file, your program should close it. If you don't and you're reading from it and your program ends, that's assuming your program ends. In this program, when I open the file, my next thing is probably look at all the text that's in there and change it, and my program is going to be running for a while, probably. If you don't close the file when you're done with it, it's open and nobody else can open it. And I could have this program running for half an hour. That file is open the whole time if you leave it that way. Bad programming style. If your program ends, Windows will automatically close your file for you. But that's poor programming practice. So here we are once again. We've opened it. And what I immediately do is write code to close it. The command for closing it includes the file pointer, that thing you're pointing to. Hey, you file Streamreader thingy pointer. Whatever you're pointing to, close it. Send some magic signal that we don't care about to Windows saying I'm done. Go ahead and let anybody else use it that wants to. Close it. Even when I'm reading from the file, how long do you think it takes to get from here to there? Maybe a second, right? So this is very efficient. Opens it, gets what I need out of it, and immediately closes it again. This is why usually you don't have a whole lot of file conflicts, meaning 2 people trying to open it, or 2 programs trying to open it at the same time. Because as soon as you're done with it, you close it, get it out of the way. Questions about any of that? Okay, so we read, we created a pointer, we did that. We opened it for text. There are other options. We're not going to use them. All we're reading from when we read from a file is text. But we discovered at the end of the last class that if we run this and the file isn't there, this command crashes. We have an uncaught exception. Exceptions are what occur when a program crashes at runtime, when it's running. We could put a try catch around that, right? And say if the program crashes, must be because the file wasn't there, and we could go display a message saying couldn't find it. To me, that's not what exceptions are for. They were really easy for you last semester to teach you to just put a try here and a catch here, and if anything goes wrong, a message pops up and says something went wrong. I don't know what it was. Maybe you could figure out what's wrong. In this case, it could be that the file wasn't there. You'll see a lot of examples where they use try catch and just say whatever goes wrong, catch it here. I'm not a big believer in that. There's a use for exceptions. We'll see them later. To me, if you can anticipate, you, the programmer, anticipate the problem that might occur, you should write the code to deal with that. So the problem that might occur is what happens if the file doesn't exist? Then the program crashes. Well, can I anticipate? I just did. Can I write code to find out if the file exists? Yes. The file class. We've seen a file, a Streamreader class, right? And a file class, that's what we use to open here, the file class. That same file class includes a method that allows you to check to see if the file is even there. Does it exist? What kind of method is this? What return value does it give to you? What type? A double? Integer?
Boolean.
Boolean. It's a yes, no. It either does or it doesn't. It's a Boolean method. It's a Boolean method that tells me if that file exists. So before I try to open it, I can check to see if it exists. If file.exists, and then the same file name, notice that's why I used a constant, so I don't have to type it in there and have to change it in 3 different places. 2 so far. Just a little bit of review from programming logic beginning. If statements, lowercase if, parentheses around the condition. These parentheses belong to the exists. The exist method wants to know, what do you want me to check? Here, this file, does it exist? Where's it going to look for it? Same folder as the executable, because we didn't designate a path. If it's true, then do all this stuff. Otherwise, so I'm down below the in file close statement now. There's no reason to close. It's legal to close a file that you never opened. Just doesn't make a lot of sense. Okay. Else, I didn't find it. I don't need this message box anymore, so let's pull that up inside here and say, whoops, just type it again for me, message box.show, data file not found. So the logic here is if the file exists, process it, otherwise show a message to the user saying, I couldn't find your file. I'm taking control of the errors here and what I want to do with them. Instead of having a try catch, if something else fails, the try catch gets caught on it. What I've discovered through experience is if I use try catch to catch errors, I can't tell what's wrong half the time. Something's wrong is basically what try catch can tell us. Now there are other versions of try catch that are smarter. Try, and if it's a file not found exception, catch it here. If it's a file too small exception, I don't even know what they are. It's just too complicated for me. This is, to me, is easy. If the file exists, process it. Otherwise, tell them it's not there. Remember, the message box has a 4 components now, because you're programming logic intermediate students. You should always use at least 4 components to your message box. That's the message. This is the title that goes on the message box. Then we get to designate the buttons. So I already forgot here, this is message box buttons. All the user can do is say, okay. Later on, we'll have yes, no buttons to process. But for right now, all the user can say is, okay, I guess I'll have to go figure out why. Comma, now I need the, did I do something wrong here? No. Yeah, but trying to figure out why it's asking for buttons now. Notice there are 21, that's what this means down here. There are 21 different versions of the message box command. It hasn't quite figured out which one of those versions I'm using, so I have to be smarter. Message box icon dot error. I'm sitting in on the intermediate iOS class. I'm not teaching it because I got too much other stuff to do. I'm sitting in on it to learn what I can. And this last Tuesday night, I was sitting there in John's chair, and I know what it feels like to be you now. Because Sean teaching it, went about as fast as I do, and trying to keep up with me typing up there, that's hard. That's why I often suggest that you assume the Kyle position. Show me. Perfectly acceptable. All right, so there's my message box. I could test that. You don't have to follow. How would I test it? I got to get rid of this file. I don't want to get rid of it. It took me forever to type it or create it. At least 2 minutes. Just add an extra letter on the end, change its name somehow temporarily. Do you know what you're doing? Yeah, sort of. Run it. Open, file not found. Now, instead of just data file not found, I could actually put the file name in there, right? So you can make your error messages as elaborate as you need them to be. So let's tweak that real quick. Instead of data file not found, I'm going to say file name plus that text not found. And since we're being grammatically correct, let's put a period on. Now my message box is even more elaborate. I can still test it, and you'll have to trust me that yours will work as well. There it is, roster.text not found. My program doesn't crash. The key part here is the exists method. How do you know what all these methods are? It's what notes, books, examples, etc. are for. Every now and then I get really crazy and I type file dot and I go scrolling through, look at all these things we can do, and you got to be really bored. But that's why occasionally one of you is going to find a method that I've never heard of, never found. Cool, tell me about it. So I can share it with everybody else, particularly if it makes our life a little easier. So that's how we can tell if it exists. Now we're ready to start processing that file. The Streamreader class, remember it's a class because it's, last class, RDD, Karen was talking about talking the talk, right? We've been doing that fairly well. I'm just going to keep using these words over and over and over again. This is a class, Streamreader, that's built in. A class has sometimes data in it, but what it really has in it that's really powerful are all these methods that can do things, like see if a file exists. Right. For file. That's a different class. To really simplify it, and it's using the wrong terms here, it's kind of like a type. Types are used for integer and Boolean and double. All those do is store one value of a primitive type, is what they're called. Just one number, one string. This is a class. It has more capability, it has built-in processing. The Streamreader class has built into it a method called Readline. Remember, and it also has a little bit later read. Not later, but read. Read is one character at a time. Now imagine my roster file reading it one character at a time until the problem with that is I can't see, I need to see groups of characters. I need to see parentheses, I need to see 8 digits of numbers. So I rarely read one character at a time. It exists, but I hardly ever use it. Instead, I use read line. Read an entire line of text. if we're going to read an entire line of text, we need to put it somewhere. So I'm going to create a variable of type string. So when I read it from a text file, it's a string. And I'll call that one line. Because that's what it is, one line of text. And so now down here, where it says read the contents of the file, I'm going to use that command. And the notes tell us that the way you use this is you call the readline method for whatever you're pointing to. You read one line. That is a string method. It sends us back a string. We want to save that. Instead of something, I called it one line. So in here, I'm going to say one line equals my infile.readline. Parentheses. Why do I have to put the empty parentheses there? It's a method. Whenever you call a method, you must have parentheses. Sometimes we put stuff in the parentheses because that method needs information to do its job. Which file do you want me to check for? Sometimes we just put the parentheses, leave them blank, like there and here. To close a file, I don't need any additional information. Hey, you, file pointer, whatever you're pointing at, close it. Hey, you, file pointer, whatever you're reading at, give me the next line. And then we write additional code to say, and save it in there. How many know if that worked? Let's add it to the text box. Text contents, contents of my file. That's that text box that's on the form. This guy, right here. Text contents. Dot text plus equals, concatenate whatever's in there with one line. So take that one line that we just read from the file and concatenate it to my text box. Now you might remember from Unit 6 that if there's a lot of lines here, this could be kind of slow. Concatenate, concatenate, concatenate. We'll deal with that in a little bit. I just want to see if this works. We're reading the first line. I have a fear. I have a fear that the first line in my text file is blank, or a space, or 5 spaces, and how am I going to know if it worked? So let's tweak that. Maybe save this just to be safe, but let's go. I'm going into my folder. There's my roster.txt file. Now that I've proven that it works, I need to take the X back off. Yours probably doesn't have an X. If you can go find that, you can open it, go to the top, and just erase all the blank lines at the top so that the file starts with the word spring. We don't have to do this, but it's going to help us with our test. A little later, we're going to write code saying, read some more, read some more, read some more. But right now, I just want to make sure I can read one. And if it's blank, that's not helping me test anything. I could just put my name on that blank line instead of erasing it. Could do all kinds of things to test this, but I want to make sure it works. Close that and save it. And now I should be able to run this, hit open. It will open the file, grab the first file, stick it into the text box, and then close it. We're reading from a file. Cool. That's one line. How many lines are in that file? I don't know. Do you? Could we find out? Probably. We could go through and manually count them, heaven forbid. We could suck it into Visual Studio. We could bring that roster text file in here and check the line numbers. Too much of a pain. And what happens when we add 2 lines? And we have to update our program to read another line? No, 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 no. How do we know when we're done? I want to do this. Read a line, add it to the text box over and over and over again. That means, you saw it in the notes, but what does that mean? Over and over and over again. Loop. Okay, now we can go back to the Unit 6 notes, and there's a flow chart that says what kind of loop to use, right? Do we know how many times we're going to read from the file? Zach says no. No, so I can't use a for loop. If you know how many times you're going to loop, you use a for loop. I don't know how many rows are in that file, lines. So that takes that out. Do we have to read at least once? No. Could the file be empty? Yes. So I don't have to even read one line. So we're going to use a pretest loop because I could skip the processing altogether. How do we know when we get to the end? Whoa, good question. End of stream. The file pointer has built into it an end of stream property. Notice it doesn't have parentheses. That's how I know it's a property. Some things get parentheses, some things don't get parentheses. How do you keep it all straight? You do it 8 hours a day, 40 hours a week, 50 weeks out of the year. After a while, it sinks in. Or you look it up in the notes, or you try it. Put parentheses on, and C# goes, it's not supposed to have parentheses. Oh, okay, take them off. You leave them up. I need parentheses here. It'll basically tell you. You put them on. And after a while, you remember. Definitely complicated. So, this is a pretest loop, right? Because we're testing right away. And this says, and Sam's back there scowling, so let's try this. Is that better? If you can't see, somebody let me know. I can see it great. Pretest loop. We wrote very few of these last semester. This says, as long as it is not the end of stream. C# is one of the few languages that uses end of stream. Most languages use end of file. EOF. You'll see that abbreviation a lot. In C#, it's end of stream because we're using Streamreader, so they made up their own rules. As long as it's not the end of stream, what this is really doing is, hey, pointer, are you at the end of the file? How would it know? Windows puts a secret little code at the end saying this is the end. We never see it, but Windows knows. And so our file pointer, are you pointing to the super secret end of file character, whatever that is for this operating system? If you are, then there's nothing more to read and let's quit. But if you're not, let's keep reading. So now what we have to do is wrap, this is a Volcker term, wrap a loop around this. We proved this works once. Read one line, threw it in a text box. Works. Now I want to do it over and over and over again. We figured out it's a while loop. While. It's not the in file dot end of stream. Curly bracket. Put all this stuff inside the loop. Do we put the close inside the loop? Are we going to close it over and over and over again? No. Are we going to open it over and over and over again? No. If we did, would that work? No, because every time you open it, it puts it back at the beginning. It'll never hit the end. That would be an endless loop. So I have to be careful. Open it once, read potentially thousands of lines, and then when you're done, close it. Kyle, does that make sense? It's because he's not typing furiously, figuring out why he's got red squiggles. How about the rest of you? Make sense? Pardon me?
How do you format?
Format what?
All the text.
Why would you? His question was, why would I? How do I format that? Because he's looking at the results. It works, right? And he's seeing hundreds of lines that I read from my web page. You're me now, right? Would you want to go into that text file and say, there's too many spaces, take these blank lines out? For hundreds, I put all 5, 6 of my sections in that one file because I wrote my program to read multiple classes. Would you want to go through and manually take all the blank lines out and all the extra spaces and I don't need this and I don't need that? No. How do I format it? I don't. I write code to deal with all the excess junk so that I can leave it in there and my code just ignores it. I'm not trying to make a pretty, what I'm getting here is an echo is what I call it. An echo of what's in that text file. Exactly, character by character, what's in that text file. Maybe he's seeing something that I forgot about. Let's run this. Go. Why is it taking so long? Because we're modifying the text box, but he's right. This is supposed to be over, and this is on a new line, and there's blank lines in here. What did we forget to do? After every line, we concatenated it, but we didn't concatenate a new line. But wait a minute, we read lines. Didn't it have carriage returns in the text file? Yes. The readline command absorbs that carriage return. It's not part of what it reads. It reads until it hits the carriage return, then it quits reading. That's a line. So there's no carriage return. So here, if we want carriage returns, you don't always, if you want carriage returns, we have to concatenate a, how did we do that? \rn, right? Those are slashes. Or you could say environment.newline. This is a little easier. Many of you created a constant called CR for carriage return. Perfectly acceptable. Vaguely remember all that? Now the other problem, it took seconds to read this lousy text file. That shouldn't take that long. It's not taking that long. It's because we're over and over again, we're going to the text box saying, give me what you got. Now attach a new line, put it back. Go back to the top of the loop. Here's another line. Give me everything you got. Attach what's on the end, put it back. Over and over and over again. What are they doing out there? Oh, it's the blind day. Okay. Only happens once or twice a semester. So what we're going to do instead is create another string. This is what we did last semester as well, called results. Initialize it to the empty string. All of the text from the file concatenated into one big, huge, ugly string. Isn't there a way to just say, give me everything out of the file? There might be. I haven't found it yet, and it's pretty useless. Why would I want everything at once? Normally I don't. Particularly if it's a huge file, now I'm sucking up memory. I usually want to process one line at a time. So now down here, instead of putting it in the text box, we're going to put it into results. And then when the loop is done and results is complete, then we say take results and put it in the text box. It's the same thing we did last semester with those. What was it? It wasn't nickels. Nickels never got big enough. But it's one of those examples that we did where it just got so big it took seconds, heaven forbid, for the results to show up. Now when I run it, blink. Notice all the carriage returns. The blank lines are there. This looks exactly now. Looks, if I wanted it to, exactly like what's in that text file. What happens when I open Notepad? Same thing. If Notepad were a C# program, it would be reading from the contents of that file and showing it to you with carriage returns in place. And so now it's a text file, right? And in here I can say, I can edit it. Volker did this. But we haven't written any code for save yet. That's next. but we're reading it. This is a very valuable skill. And notice how hard this very valuable skill is. If the file exists, open it. As long as you haven't hit the end, read one line at a time, and then spit it out. Close the file. Very, very handy. A lot of people use flat files like this, a text file, as a database. Because I could put Aaron, comma, Spate, comma, IT software developer, comma, on and on and on. Any information I want about him on one line, read it, figure out how to take it apart, process it. Then go get the next line. John, comma, O'Leary, comma, IT software developer, comma, et cetera, et cetera, et cetera. I can read one line at a time, process it, do whatever I need to do. Classic technique. If the file is empty, this is already false because, or this is true, not true is false. I'm at the end already, quits, never reads, shows me an empty text box, closes the file. Because the file might be, maybe it's a file of delinquent accounts. File of students who are failing RDD right now. None. Good to know. Then I could run the same program again 2 months from now, and hopefully the answer would still be none, but it might not be. Questions? See if I skipped anything in my notes. Close file. Did that already. Another reason to close your file, besides the fact that you don't want to be not manipulating it, but monopolizing it for all other people, is you might need to open it again and start over, read from the top. Maybe I want to find Kyle's record. Well, he's not number one. Is this Kyle? Is this Kyle? Is this Kyle? Nope, 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 nope. Oh, found him. Done. At that point, even though I haven't read the whole file, I could say, close it, done. And now I want to find Trevor. Open it up again, start at the top. Trevor, nope, 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 nope. Oh, found him. And if you need to open it and it's still open, you won't be able to do it. This is the main reason. Good programming style to close anything that you open. There's the command. We've already done it. Should probably push that up in my notes because I do it right away. Perfect. There's nothing more to reading from a text file. You got it all. Now, what we do inside here, do you think it's 2 lines of code in my import the students thing? No. Take one line. Is this what I'm looking for? How do I even know what I'm looking for? I, the programmer, have to figure that out. And then what happened? 2 years ago, they changed the way the names appear on that screen. I changed my program to update with it, keep up with it. That was painful. Right now, this is simple. Whatever you got out there, just spit it back out at me, show it to me, echo it. But normally, you're going to do something with it. Why was I trying to find Kyle's record? Because I wanted to find his phone number. We'll display his phone number. If it's a mobile device, maybe even call him, right? Same kind of stuff. Let's take 10. We'll come back and learn how to write to a file. Take that Volker did this and actually save it.